Okay, so neurotype defect is one of the most common congenital abnormalities in the United States and other countries. At the beginning of the pregnancy, in about 28 days of pregnancy, the embryonic neurotube closes, and when that fails to close properly, two main abnormalities can happen, which is anencephaly and spina bifida. Many components can affect pregnancy for that to happen, like genetics, family history, and previous affected pregnancy from neurotube defect. In 1976, there's a study that found micronutrient levels, including folate, were low in mothers who gave birth to children with neurotube defects in the United Kingdom. Large reductions in neurotube defect risk in future pregnancies were observed in 1980, 81, and 83 when a non-randomized intervention trial was conducted in the United Kingdom where a multivitamin and multi-mineral supplement was administered to women who had already experienced a neurotube defect pregnancy. So further researches from 84 and 86 also review that drugs that interfere with folic metabolism increases the risk for neurotube defect.
Several case control and cohort studies have been conducted to analyze the relationship between folic acid and neural tube defects. 4 of these studies examined folate from dietary sources, and an inverse association with NTD risk was found. Strong inverse associations were also found in a study that evaluated the effects of a folic acid-containing multivitamin during the first 6 weeks of pregnancy. In another study, blood samples from pregnant women were taken and analyzed. 84 pregnancies were affected by NTDs, and both plasma and red blood cell folic acid levels were lower in these cases, supporting the inverse relationship. The clearest evidence of the causal relationship between folic acid and NTDs comes from a randomized trial where women with a history of NTD pregnancies were given either a high dose of 4 milligrams of folic acid daily or a placebo. A 72% protective effect of folic acid was observed. These types of trials can raise ethical concerns. For example, in a study conducted using women without NTD history, 6 pregnancies with NTDs occurred in women taking the placebo, and the study was stopped early because of this. Although unfortunate, this result is significant. Additionally, the women who were taking 0.8 milligrams of folic acid did not experience NTDs in their pregnancies. It is interesting to note that in this study, risk of other congenital abnormalities was reduced in women taking the supplement, which sparks curiosity about the other benefits folic acid may have in pregnancy. In a geographical context, the difference in NTD risk for northern and southern China was brought closer together after a large intervention study that advised women to take 0.4 milligrams of folic acid daily, resulting in an 85% reduction rate. To summarize, studies conducted on the relationship between folic acid intake and NTD risk suggest an inverse association with the recommendation of 0.4 milligrams daily for prevention. These findings merit further research, particularly related to prevention in women with NTD history and how we can relate these findings to impact folic acid policies.
As far as policy being impacted by this research, there is a lot of controversy surrounding policies related to the relationship between folic acid and NTD risk. Policy responses have been unclear, but one thing that is that low folic acid intake increases NTD risk. The research has informed us of 3 possible strategies for increasing a population's intake. The first strategy would be to increase the intake of foods that are rich in folic acid, such as fruits and vegetables. This would increase the intake of beneficial nutrients and phytochemicals. However, folate contained in foods has low and variable bioavailability compared to pure folic acid. Therefore, large increases in intake and blood levels are needed for maximum benefits. Also, price and availability of fruits and vegetables can be barriers in low-income populations. A second strategy would be to recommend to females a folic acid supplement of 0.4 to 0.8 milligrams a day and 4 milligrams a day for those who are already at risk. The cost is modest in comparison to the cost of buying fruits and vegetables. But not all women are willing to comply with this recommendation, and a basis for risk screening has not been established yet. The third strategy would be to fortify the food supply with folic acid. In 1998, the U.S. mandated that all flour be fortified with folic acid. NHANES data and 24-hour recalls showed an increase in the median intake of approximately 0.1 milligram a day. However, only 23 to 33% of the population actually reached the intake of 0.4 milligrams a day. Still, the rates of NTDs declined in the U.S. after fortification. The good thing is that fortification can reach almost the entire population. It does not depend on education or motivation, and it can also reduce the risk of coronary heart disease and stroke. However, there are still some uncertainties about the appropriate amount of folic acid needed to reduce NTD risk while avoiding toxicity and masking of other health problems. Also, not all ethnic groups can benefit from fortification. For example, Mexican Americans are largely unaffected by fortification due to their consumption of cornmeal.
Okay, so in summary, there's strong evidence showing that the use of supplementation, pure folic acid, early in pregnancy can significantly reduce the risk of neurotube defect. Researches on the effect of increased folic acid on a neurotube defect has been primarily conducted through various cohort case control studies and randomized as well as non-randomized trials of folic acid levels found in blood samples. The dose for 0.4 micrograms a day or less added to dietary sources showed a strong association with full benefits, and genetics and diet association is still in need to more researches to establish the interactions and determine optional levels of food fortification. It has been significantly noted that researchers done with genetic markers is also necessary because past family histories of neurotube defect is a potential risk factor as well for this condition.